Good day, everyone, and welcome to another exciting edition of Grade 12 Mathematics with your bright brainiac tutors. Before we get started, I would like to ask you to please not forget to hit the subscribe button and like the video for more of our content, and leave a comment down below on which topic you'd like us to cover next. So today we'll be looking at some Grade 12 trig, and we'll start off by looking at the weighing of trig in your paper 2 final exam, which means we'll look at how many marks in total you can score for trigonometry in your finals. And then we will look at the NSC exam guidelines that pertain to trig, and that means we'll just look at what to do and how to prepare for your final exams. Then we will travel back into time with our bright brainiac space-time machine to revise our grade 10 and 11 trig content. We'll then go straight into the grade 12 content, which will then be followed by a short question as a way to flex our brain muscles. So without further ado, let us get cracking. So as you can see from the weighing of topics per paper for grade 12, that your trig is 50 marks out of a total of 150. So that means that trig is basically like a whole third of your paper 2. Thus, it is kind of possible to pass paper 2 just by knowing trig and getting full marks in your trig. So below, as you can see, are just a few of the exam guidelines for trig as just 2 points, and we'll look at the second point on our second video series of trig. The reciprocal ratios cosec, sec, and cot can be used by candidates in the answering of problems, but will not be explicitly tested. So that means the question will not include any reciprocal ratios, but if you feel you can solve any trig identity or trig equation by using them, then you can do so. That's what the first point means. Then we'll just look at the second point when we do the second video series, and this whole section or this whole slide of the weighing of the various topics in Maths Paper 2 and the exam guidelines provided for trig in this slide are from the Mathematics Grade 12 exam guidelines. The link to download this booklet is on the description below. So in grade 10, you were introduced to the fundamental building blocks of trig, and now we'll briefly look at those building blocks. In a right angle triangle, we use special words to describe the size of the right angle triangle. The longest side is the hypotenuse. The side that is next to the given angle is the adjacent side, and the side that is across the given angle is the opposite side. And basic trigonometry only works for right angle triangles. And so we have a special mnemonic that is called the Socatoa. The Socatoa is a helpful mnemonic for remembering the definitions of the trigonometric functions sine, cosine, and tangent. Sine, which is so, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Toa, tangent, is opposite over adjacent. So then we'll look at the reduction formulae, which was taught in grade 11. So you were taught in grade 11 that any trig function whose argument is 90 plus minus theta, 90 plus minus theta, or 180 plus minus theta, and 360 plus minus theta. These trig argument function can be simply written in terms of theta. So if you have this 90 plus minus theta, you can either write it as maybe positive sine theater only without the 90 if that the example was sine 90 plus minus theater, and then you could write it as simply as this. And you learned this in grade 11. So this is where the cos diagram came in. So the cos diagram helps us to remember the signs of the trigonometric functions in each of the quadrants. The cos diagram is also called the quadrant rule, which has four quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. And the cos rule says that in quadrant 1, which is between 0 and 90, that all 3 of sine, cos, tan are positive. In quadrant 2, which is 180, only sine is positive, cos and tan are negative. In the third quadrant, which ranges from 270, tan is positive, sine and cos are negative. In the last quadrant, which is the fourth quadrant, only cos is positive, sine and tan are negative. So a useful mnemonic you could remember this is that all stations to Cape Town is a useful mnemonic to remember this. So next up, we'll look at some basic identities. So an identity is a mathematical statement that equates one quantity with another. For example, in this statement, cos squared theta plus sine squared theta is equals to 1. These are proven identities, and sometimes in question papers you are required to prove some of the trig identities. And the trig identities that you need to prove are also in your exam guideline booklet, which, as I said earlier on, is the link to download it is on the description below. So trig identities, as I said, will allow us to simplify given expressions so that it contains sine and cosine ratios only, because they'll ask us to prove ratios or to prove that one side is equal to the other side, and then we have to use basic identities or compound angle identities to replace and then get a simpler answer. So this enables us to solve equations and also to prove other identities using these identities. So you don't need to remember what all the identities are, as they are in your grade 12 information sheet. So you don't need to memorize all the identities. You just need to memorize the proving of them, by the way. So we'll look at a typical exam question, and the question goes like this. P that has coordinates -√7 and 3, and S that has coordinates A and B are points on the Cartesian plane as shown in the diagram below. Angle O, which is in triangle POR, and angle O, which is in triangle POS, are both equal, and which makes them equal to theta. And the line, which is this one, OS, is equals to 6, right? To solve this question, firstly we need to construct triangles and put in certain variables to make it make sense to us. So then this is a reconstruction of this triangle, right? So we use the coordinates P, which is -7 and 3, because that is the x coordinate. That means the adjacent side will be -√7 and our opposite side will be +3, right? So then we jump into the questions. 3.1.1, what is tan of theta? So you can pause the video and then just figure it out for yourself, and then just look at the answer after you figured it out. So tan of theta is, you have to always write your mnemonic to help you, Socatoa, right? And in this case we're dealing with the tangent, which is opposite over adjacent side, right? Our opposite side is 3 and our adjacent side is -√7, right? So 3.1.2, right, asks for sine negative theta, right? The reduction formulae for sine negative theta is just negative sine theta. And then we will say the problem is sine is opposite of a hypotenuse and we do not have the hypotenuse side, right? To figure out the hypotenuse side or side, the hypotenuse side, we then use the theorem of Pythagoras, right? The theorem of Pythagoras states that r squared in a right angled triangle is equal to x squared plus y squared, right? So in this case, x squared is negative root 7 squared plus y squared, which is 3 squared. Negative root 7 squared is equals to 7 plus 9, which is therefore equal to 16, and that is r squared. So r squared, to get rid of the squared, we will square both sides, and r squared will then be r is equals to root 16 is equals to 4, right? So our hypotenuse is 4, right? Therefore, negative sine theta is the negative, and our opposite side is 3, and our hypotenuse is 4. Therefore, 3.1.4 is equal to negative 3 over 4. So then 3.1.3 want to know the coordinate of S, which has a placeholder of A, right, or a variable of A, right? So to get that, we need to reconstruct the second triangle, which is this one, right? So we have reconstructed it, and therefore that the adjacent side will be A, and the opposite side will be B, right? And we know the hypotenuse is 6, right? To get any side, right, without two or more sides, we're going to use two sides without two sides, and we need to get another side. What we use is trig functions, right? So what we do is we always put the unknown side, the one we're looking for, over a known side, right, which is 6. So that unknown happens to be the adjacent side, and that unknown and the known side happens to be the hypotenuse, right? So a over h is cos, right? So therefore that will be cos 2 theta, right? That will be cos 2 theta, right? So a over 6 is therefore equals to cos 2 theta. Cos 2 theta is a special angle, and therefore we can really replace it, right? Therefore A is therefore equals to, take the 6 to the other side, and let's replace cos with 2 cos squared theta minus 1. We replaced it with another trig identity, right? So then we'll do a few calculations, and we know what cos is, so we'll just have to square that, right? Okay, let's take the 2 out. 6 times 2 will give us 12. And then what's cos squared theta? Cos squared theta will be adjacent over hypotenuse, right? Our adjacent side is negative root 7 over 4, which is our hypotenuse, right? Square that, and then we times that on that side to get it on the other side. 6 times negative 1 is negative 6, right? And that's what we're left with, right? Which will then equals to 21 over 4 minus 24 over 4. which then simply equals to negative 3 over 4, and that is 2.1.3. So then I would like to encourage you to do 3.3 on your own, and we'll post the answer on our Facebook page at Bright Brainiac Tutoring Services. Right? That is it for our video today. Please leave a like and comment, and most importantly, please subscribe. On our next lesson, we will complete the trigonometric series, and thank you for watching.